So let's move on to your book itself, which is titled Seriously Good Software. The term seriously here, I think must mean something, right? So maybe you can tell us a little bit more. What do you mean by seriously good software?
So what I mean by that, even though the title was Manning's idea, I was going for more something like exercises in style, because the main idea of the book is to present the same small class, same small toy example in many different ways, optimizing for different software qualities. Maybe we're going to talk about that later. So Manning came up with this title. It's probably more catchy. I trust them. They're great. They have a great marketing department. So I trust their feeling. So the idea of the title and the idea of the book is that seriously good software is not just software that works, that it's not just software that satisfies its functional requirements, so it does the right thing, but it also does it in the right way. And of course, there's many different ways to measure how fit and how good your software is. For example, you have readability, so which is a non-functional quality because the end user is not aware of whether your software is readable or not. But it's still a very important quality because it affects maintainability. So software is certainly going to have bugs. It's certainly going to need to be modified, extended. And according to how readable it was, it's going to be easier or harder to fix it or modify to evolve it in general. So that's just an example of a non-functional quality that is often undervalued. So at least, once again, from my educational point of view, we mostly focus on functional qualities in education, but I think there needs to be more focus, both in education and in some industries, on non-functional qualities, things that are not immediately visible outside, but are still very important for the future evolution of the software or for its performance.
So speaking about not just about functional requirements and not just whether it works or not, whether it gives you the right output, but there are also other qualities, which probably we'll discuss a little bit further. But obviously, there are so many software engineers, or maybe not just software engineers, sometimes because of the demand from either like the business people or from the company to just produce software as fast as possible. What do you think we can do maybe as a profession or as a software engineer, what we should do in terms of personal situation if we are about to write this kind of software? How should we convey the message that actually the things that matters is not just about whether it's working or not based on an input and output?
I think you can approach the problem at different levels. For example, if you're a junior programmer, so then maybe you don't have the power to fight. So you're just given a deadline and you have to do your best and you cannot move the deadline. You probably cannot even argue for different objectives, different requirements. So what can you do as a junior programmer? As a junior programmer, I think you should, first of all, develop an awareness of the different ways you could be programming your little function or your little class or your large subsystem. And of course, this comes naturally with the experience, but maybe my book can give a little help there. Cultivate this awareness that there's 1,000 different ways to program even little units, even a small class, sometimes even a small function. You could do that 1,000 different ways, and maybe they'll take the same time to you. So it's not that you have to think for a month to find the best one, but if you just cultivate this awareness of the possibilities of the variety of ways, and you get used to it, then maybe in that short time that you are given, you can do something better. You can evaluate different possibilities in your mind quickly. You're not going to spend a long time doing that. If you're used to it, the different possibilities just come naturally to your mind. And of course, experienced programmers, I think, can naturally go into that state. But junior programmers need to actively pursue this mindset, I would say. And then even in your little space and in your little time that you're given, you can do something better. You can evaluate different possibilities and pick the right balance. And let me also add that the right balance between different qualities, balance between performance and readability and so on, and robustness and so on and so forth, and the right amount of testing, etc. This right balance depends on the context. So you should be aware of the possibilities and at the same time aware of the context of your application. And depending on the type of product you're making, you should emphasize one software quality over the others.
So speaking about software quality, I know that you have this quadrant that you mentioned in the book, which is a quadrant about internal versus external qualities and also functional versus non-functional qualities. Maybe can you give us a little bit of overview? What do you mean by all these different quadrants?
Yes, I have these two distinctions. Of course, they're classical software engineering categories, so we did come up with them. So the first one is internal versus external qualities. And this is the distinction between qualities that the end user can actually see. And these are called external qualities. So for example, correctness, of course, functional correctness. So the program does what it's supposed to do. It provides the right functionality. That's an external quality. And the time performance is mostly an external quality. So if your program takes 1 second or 10 seconds to perform its actions, that's very visible to the user. On the other hand, so the distinction is not so clear cut, because if your program takes 1 millisecond or 2 milliseconds, you can argue that it's visible or not. Well, it depends. If it's a user-facing program, then it's not actually visible because it's exactly the same for the end user. On the other hand, if it's a service that's going to be used inside a larger program, it may become visible. That single action, the 1 versus 2 millisecond action, is going to be taken 1 million times in a row. Then, of course, it becomes visible. So that's the first distinction. The other way to distinguish software qualities is functional versus non-functional. Once again, functional means what the program does, like correctness, does the right thing or not. And non-functional means how it performs the task. For example, how much memory it takes, how much network bandwidth it requires. Those are non-functional qualities. Readability, which I mentioned earlier, is one of the major non-functional qualities because it's both internal and non-functional, but it's still a very important quality, as I was mentioning earlier.
So when you construct this quadrant, right? For example, you have maybe internal and functional and internal non-functional and vice versa. So in your view on this, is there any quadrant that is more important than the others? Or how should we read this quadrant? Because there are probably different qualities that reside in each of the quadrant.
I don't think that in principle, any quadrant is more important than others. I just think it's a useful mental tool to have. Also, I think that in some education and some industries, they perhaps put too much weight on some of these quadrants. Particularly, they put too much weight on external and functional qualities and too little weight on the others. Whereas I think in principle, they're all equally important. Or if you want to be more precise or more specific, in different contexts and in different industries, one quadrant may be more important than others, but not in general. Really depends on the context.